For point 1 here, the first problem here is to determine whether or not the following distribution is a probability distribution and explain your answer. Remember, for it to be a probability distribution, all the probabilities, so all of the values in the second row here, all have to be between 0 and 1, and they all have to add up to 1. So in this case, for instance, this one here is negative, which means that this cannot be a probability distribution. If they were all between 0 and 1, and they add up to 1, then it would be a probability distribution. But since we have a negative 1 there, even though if you add up those probabilities there, if you did the 0.2 plus the negative 0.1 plus 0.6 plus 0.3, if you add those up, you will get 1 there. But the reason why it's not a probability distribution is because you have a negative 0.1 for a probability, and you can't have negative. Can't be negative. So if you have a probability that's negative, right off the bat you can say that it's not a probability distribution. And then for the next one here, what we have is we have to find the expected value and standard deviation for this probability distribution. And once again, like the other ones here, what we have is we have this table that I set up. Once again, this type of table here will not be given to you down here on a quiz or test. So you want to make sure you remember how to set it up. All that will be given to you is this original one that has the x and p of x for the probabilities and the values there. So something to keep in mind there as well, that you want to make sure to remember how to set this up and what these symbols mean. So the expected value, another term for that is your mean or your average, which whenever you're finding it using your probabilities and your values here, to find that, what we do is we do x times p of x. So I didn't include a column for that here, so I'll write it off to the side. So all you're doing is multiplying those first two columns together. So the first one there would be 0. The next one there would be 0.1, 0.4, and then 1.2. And then to find the expected value, which is your mean, since we're dealing with the population, these are all the possible values here. The population mean, remember, is this symbol mu. It looks kind of like a cursive U. It's going to be what you get whenever you add up these values. So if you add those up there, you should get 1.7. So that's your mean, which is also the expected value. So I'm just going to abbreviate it here, expected value. So that one's the quick value. We need to find that first before we can get to our standard deviation, since you'll notice for that next column, you have to do your value, so your x value, minus that expected value, the mean, for that column, in order to come up with those values here. So let's type those in here. You should get 0.3 for the, or sorry, that was what the probability was. So we'd have negative 1.7. There we go. And then a negative 0.7, because you always do the value minus the mean. Remember, the first one there is 0 minus the 1.7, then 1 minus 1.7, which was the mean. And then the next one there, we should get 0.3, and then 1.3 for those values. And keep in mind here, I did write it down, that the column there that had the probabilities, those probabilities always need to add up to 1, just like we discussed in example 1. Otherwise, it's not an actual probability distribution. Okay, then the next column, you square all the numbers. So in other words, the negative 1.7 times negative 1.7 is the same thing as squaring that. So all the values in this next column should be positive if you're doing them correctly. I'm going to type in what you should get for those here. You want to double check, make sure you get the same values. And then the last column there, we need to do those answers that we just got in that last column times the probabilities. So it's similar to how we had to find our standard deviation before whenever you're using our class width and our classes that we had from before. But now instead of dividing by the total, we have to multiply by our probabilities. Remember, probabilities already have how many values there are included in that calculation. So our next step is to multiply that probability times the values in the previous column. So what we should get are these values here. I'm going to type them in. So again, good idea to go through and double check here. Make sure, see if you get the same thing or not. And then for this one, what we'll want to do now is add up those values. And remember, in general here, we want to go at least 2 decimal places. The more, then the more accurate it'll be. So something to keep in mind there as well. So here, whenever we add up this column, this value here, what we get for that sum is our variance. And we need that variance in order to find our standard deviation. So just like it has in the book here, our symbol here for our variance, since we're dealing with a population variance is sigma squared. That's what this little O type symbol means, is sigma. Squared is for our variance. To find our standard deviation, abbreviate here, standard deviation, SD. Our symbol is going to be just the sigma. To find that, you do the square root of the variance. So in other words, here we did the square root of that 1.61. So then here we get approximately 1.27 for that standard deviation. So some of these can get quite long depending on how many values there are. So it's a good idea to know how to set up these tables, kind of like what we did whenever we were first finding our standard deviations. In this case, once again, we start with these first 2 columns, the x and p of x, multiply them to get the mean, which is also called your expected value. Then do your value minus the mean, square those, and then multiply it by the probabilities. Once again, you don't have to necessarily include all of these columns in your work, but you do want to show some sort of work for how you're getting to those answers. That way I know that you're not just plugging into your calculator to get those answers, that you know how to actually calculate those there.